So in our quest to discover more thermodynamic properties, we've talked about internal energy, we've talked about enthalpy, we've talked about entropy. So now why not throw in another one, Gibbs free energy? Okay, so now we see we're going to define another thermodynamic property, which is the Gibbs free energy of a system. The Gibbs free energy is defined as the enthalpy of that system minus the temperature that system's at in units of Kelvin, and times the entropy of that system. Okay. So now we've thrown in another thermodynamic property. Well, it's defined by two other thermodynamic properties. Well, the important thing with our Gibbs free energy is talking about what happens to our Gibbs free energy as a reaction happens, right? We're always talking about the change of enthalpy, change of entropy. Now we're going to talk about the change in Gibbs free energy. So what we'll see is that the change in Gibbs free energy is equal to the enthalpy change minus the temperature that something is at times the entropy change. Okay. Now what's important about Gibbs free energy? It's called free energy because the Gibbs free energy change right here, that is the amount of theoretical maximum work that a system can do. So that's saying the energy available if we utilized all of it to do work. Okay? And so that's comprised of two pieces, right? Enthalpy and our entropy. So now another piece of this that we want to look at is see how does this relate to the second law of thermodynamics. So we got to the end of our last video and we looked at the second law of thermodynamics, and we said that the entropy change of the universe is equal to the entropy change of our system minus the enthalpy change of that system at a specific temperature. Okay? And we also said that in order for a spontaneous process to occur, that's greater than 0. I want to go ahead and see how these two things are related to each other. Okay? So we have the entropy and enthalpy changes here. I'm going to go ahead and multiply both of these sides by T. So we see we have T delta S of our universe equals T delta S. Okay, and I'm just going to leave this as just delta S because that's for our system, minus delta H. Okay. Then I'm going to multiply both sides by -1. So that gives us negative T delta S of our universe equals, now this is delta H minus T delta S. And what does that look like? Well, that looks a lot like this, right? And so we see, now we can say, well, that is actually equal to our Gibbs free energy. So if we say that our Gibbs free energy change equals negative T delta S of the universe, okay, well then if we're looking at what does that mean for us with Gibbs free energy and its ability to predict spontaneity, well, if we know that the universe entropy must increase for a reaction to be spontaneous, so that means that our entropy change must be positive. Well, temperature, this is an absolute temperature, so that's always going to be positive. So the only way that we would have a spontaneous process is if we have a delta G that is less than 0. Okay? And so now we see that we not only can use delta G to calculate the maximum theoretical amount of work in a reaction, but we also see that if our delta G is less than 0 or negative, that also tells us that that reaction is spontaneous. Okay? So now we see that there's a big connection between Gibbs free energy and the second law of thermodynamics dealing with spontaneity, and that we can either go ahead and predict or calculate the total entropy change, or we can say, well, let's look at it just by the enthalpy change of our system, the entropy change of our system, and if we go ahead and calculate that at a specific temperature, because we see it may be temperature dependent, it may not be, then we could go ahead and calculate the delta G value. If that Gibbs free energy change is negative, that tells us our overall reaction is spontaneous. If it's positive, it's non-spontaneous. Okay, so now we kind of have a golden rule, golden place that if we get a delta G less than 0, we know it's a spontaneous process. Okay, so in our next video, I'm going to talk about how do we actually use delta G if maybe this contribution to our spontaneity is not positive, right? It's not something that contributes to it, but this one is. How do those two things intermingle or balance with each other?